So now we want to welcome our first keynote, Dr. Jonathan Epstein. I heard this keynote in May at another meeting, and I was just so moved by his message that I wanted to share it with all of you this morning. Can you go back to the beginning for just a minute? But before I do that, I wanted to thank some of the people who have been so instrumental in making this day successful. So obviously our sponsors, we could not do it without them. Our founding members, we are also a membership organization, and so these are the members from Philly that actually had the vision and foresight to establish Philly Builds Bio 4 years ago and still going strong. And the rest of our corporate and signature members. And we have all of the incubators exhibiting here today. So they're right outside the room. Please go out and talk to them. Some of the companies that we've given complimentary registration to all of the companies that are growing in the incubators. So please reach out to these small companies and welcome them to the community and let them know that you're glad they're here. And of course, our steering committee. We have quite an extensive steering committee. We meet monthly throughout the year, but over the last 3 months, we've been meeting weekly to make sure that we have a great agenda for you and make sure that the meeting comes off properly. And all of them have been working around the clock to help with this. So we thank you all. Next slide. We just had our opening speakers. So Dr. Epstein was named Executive Vice President of the University of Pennsylvania for the Health System and Dean of the Raymond and Ruth Perelman School of Medicine on March 1st, 2025. Together, these two entities make up Penn Medicine, an almost $12 billion enterprise dedicated to excellence in the related missions of medical education, biomedical research, and patient care. As the Robert G. Dunlop Professor and most recently the Executive Vice Dean and Chief Scientific Officer, Dr. Epstein has played a pivotal role in shaping Penn Medicine's trajectory as a national and international leader in discovery, science, and clinical research. He has also served as Senior Vice President and Chief Scientific Officer for the health system since February 2021. From 2006 to 2015, he served as chair of the Department of Cell and Developmental Biology and scientific director of the Penn Cardiovascular Institute. Dr. Epstein has directed a highly impactful research program throughout his 27 years at Penn, and he is widely recognized for contributions to the understanding of congenital heart disease, heart failure, stem cell biology, and epigenetics. Welcome.
Thanks for that lovely introduction. Thanks for having me here today. Representative Gautier, your comments were just right on target, and thank you so much for being here today and for expressing them so genuinely and from the heart. How do I advance these slides? So I thought I'd give a little sort of update on where we stand in these turbulent times, the viewpoint from University of Pennsylvania, but also hopefully some ideas about directions we can go in the future that may be turn the crisis into an opportunity. So I'll summarize some of this. We're all aware that the NIH has been a driving force for innovation for many decades in the United States, making the United States the international leader in discovery science. And that partnership between academia and the government, I think, has been the beginning of the pipeline for a successful ecosystem of biomedicine, across from small spin-out companies to big pharma, and all the jobs that it creates, as Representative Gautier emphasized. But this partnership is clearly under attack right now. We've all heard and read about the challenges, grant cancellations, caps on indirect costs that keep the lights on in our buildings, a proposed 40% reduction in NIH budget, which would be simply devastating. And then, maybe not quite as apparent, attacks on reimbursements across the health system. Things like 340B, which help to pay for expensive medicines for our patients, especially for patients on Medicaid. Site neutrality, which allows for different reimbursements depending on where a patient is seen, and Medicaid cuts. And the reason why I think these are so relevant to this conversation is that at Penn Medicine and at almost every academic health system across the country, those indirect costs don't actually cover the full costs of doing the work. The margins from providing care for patients are funneled back into the academic mission for research and education. And so if there are less funds for caring for patients, the whole ecosystem of the university is truly at risk. And although we've heard about big cuts at Harvard, all their funding being cut, Columbia, Brown, Penn, Northwestern, UCLA, individual sites, it's actually, the cuts are not limited to these individual elite universities. If you just look across the board at money coming out of the NIH, as this curve shows, it is dramatically less than last year. And this is due to a host of reasons, not just the big bundle terminations, but a slowing of allocation of funds at almost every stage. So even grants that are officially awarded are not being paid at the same pace as normal. And this is particularly happening for training grants. If you look at the right, the grants that fund the training of students have essentially stopped coming in. And this really scares me, because this is the pipeline of human capital that goes on to be the innovators, to be the workforce for the entire ecosystem. So I really hope we can place attention on the need to train the next generation. And at Penn and at most of our peer institutions, we have cut the number of students who we're taking because the funding to support them has not been available. Even our historic MD-PhD program, which is the largest in the country, and we've trademarked the term best in the galaxy for this program, and truly the students are remarkably excellent. We've cut the number of slots this year for those students, which is painful. And it's not just that last year was a good year from the NIH. If you look at the last decade of rates of awarding of grants, this year is an outlier, markedly lower than all the previous years, shown in gray. So Representative Gautier made the point that it's not just about discovery science, it's about economics. And this funding coming into our region drives economic development in the region, and estimated at $15 billion and $200 million of tax revenues in the region. So the ramifications of decimating this source of jobs is going to be felt broadly. And it's estimated that every dollar of NIH funding that's invested in the country brings back about $2.50 of economic development. And that's probably a very conservative estimate, because it doesn't include all the downstream revenues of new drugs that are developed at pharma as a result of that, where it actually magnifies that return on investment quite dramatically. So this is, and if you compare this to federal dollars invested in defense and in all sorts of other domains, those pale in comparison in terms of return on investment to the NIH. So on a purely, never mind saving lives, on a purely economic argument, it's unclear to me why cutting the NIH by 40% makes sense for our country. I'll also point out that data where people have tried to look at whether NIH funding truly leads to new drugs really supports the fact that it does. And that's what my sense as well from watching the industry over several decades. This paper that was published in JAMA Health Forum looked at all new FDA-approved drugs in the decade between 2010 and 2019, where there were 356 new approvals. And 354 of them had publications funded by the NIH in the literature dating back 10 or 20 years. The curve on the one on the left is for drugs that are for new targets, and the one on the right for sort of follow-on drugs. And no surprise, the ones for new targets have a longer arc. The publications go back 2 decades when they started to appear, and for follow-on drugs, about a decade. And the problem is that most pharma and biotech companies don't have the time to invest 2 decades ahead of when something might start making money. And so why it's so critical that we have this academic-government partnership is because we can take the long view. We can invest in new ideas, even when we don't know what the drug is going to be. You know, when mRNA was developed, it wasn't clear there was going to be a pandemic. COVID had never been heard of, you know, and yet the work that had gone in over several decades was what allowed those vaccines to be made so quickly. And this won't be replaced by pharma or biotech, even if they put more money into R&D. They're not going to take a 20-year-long view with the kind of dollars that we see here. Sar Gill, who's a fantastic researcher at Penn, made this infographic to summarize this data. Again, 99% of drugs developed during that decade were funded by the NIH. In addition, the amount of money that the federal government puts in to support research at universities, and this is nationally, not just here in Philadelphia, has actually dropped over time as a percent of the total funding. So even though the NIH budget has gone up and there's more investments, the total amount of dollars that are being invested in research until this year has been going up also. And the percent that's funded by the federal government is only about half of the total funding that goes into research. Higher education itself, including those transfers from health systems, has supported a larger and larger portion of what goes on these campuses. And one reason that we've had to put more and more money into the effort is that the requirements from the federal government for how we conduct research have steadily increased, but the reimbursements for those activities have not gone up. F&A costs have been capped for a long period of time. So this graph shows the increasing number of regulations and policies that are relevant to biomedical research in academia. And you can see how they've just skyrocketed since 2015, most of these unfunded mandates. And many of them are rational. They're about security of data and care for animals that are being used. But it's just hard when you keep getting more and more requirements and you don't have the funds to pay for them. And at the same time, we're being told the indirect costs are going to be cut rather dramatically. That's an untenable position to be put in. Some of these requirements aren't so rational. And I do think there's an opportunity here in this crisis to find the ones that we could get rid of and simplify the process where there isn't people or animals' health at risk because of that. A quick word about indirect costs. I've said a little bit about it already. But there's the sense that they've been increasing, that universities are putting the money in their pocket and using those dollars for something else. I've had government representatives say to me, isn't that what you're using for DEI work? Lots of thoughts about what we use. Actually, there's a negotiation with auditors, with the federal government, where we have to show them what we spend the money on, the electricity, the security, et cetera, et cetera. And they decide what the rate is to pay us for those indirect costs. And the numbers that are thrown around, like 60% of the dollars are going for indirect costs, are reflecting the strange way in which indirect costs are paid by the federal government. Those percentages are actually a percent of the direct costs, not of the total costs. So at Penn, if you look at the bottom, our indirect rate had been 62.5%. Sounds huge. But it's not paid on all grants. Only some grants pay indirect costs. Training grants, for instance, pay only 8% indirect costs. So if you average it over all grants, the average is about 40% of the direct costs. And if you express that as a percent of the total costs, it's 30%. So 30%, and that's what a lot of families pay for the mortgage on their home, you know, the structure in which they live. It's not unlike that. We're paying for the structures in which we do the work. And if you look across the country, since 2002, at all NIH grants and all F&A or indirect costs that are paid on them, it has been remarkably stable over that period of time. About 28% of the total costs go to indirect costs, rock steady across all those years, even though the number of requirements and regulations has gone up quite dramatically. So that's just the facts. So a couple of words about what I've seen here in Philadelphia over the last couple of decades. I've been here for almost 30 years. I did all my training in Boston, where my first job was in Kendall Square. Back then, you could not buy a cup of coffee in Kendall Square, and I watched the explosion of biotech that took place there. And since coming here to Philadelphia, I've been really eager to see the same thing happen here, and I've watched the beginnings of that process take place. It's no surprise that both in Kendall Square and here, this is happening around great universities, because I think these ideas come out of great universities and then become biotechs and then are often bought by pharma. And we've seen that in this region. And when I came, there was a lot of talk at the Congress at the time about how the NIH was putting a lot of money into research and not getting enough new drugs out the other end. It was called the Valley of Death. And there were articles written about it and a lot of concern about whether this was a good investment. And we at Penn made a concerted and strategic effort to take this on. And it was previous leaders, not me, who made this effort. And they invested in a whole series of structures that helped to promote our faculty's ability to translate their early discoveries to be new medicines. Of course, it was really driven, the success was driven by the brilliance of the faculty. It couldn't happen without them and the students who worked in the labs to make it happen. But these structures enabled them. So things like the Institute for Translational Medicine and Therapeutics, an office for clinical research with nurses who could enroll patients in clinical trials. The Penn Center for Innovation, our tech transfer office, was completely reimagined. And then more recently, the Institute for RNA Innovation, that's about half a block away from here in a new building that you'll hear from Drew Weissman later. The Center for Cellular Immunotherapies, where our CAR T work was invented and where it takes place. This investment and strategic priority was really successful. The landmark day, I remember well, was when CAR T cells got FDA approval in 2017. This is a picture in the upper left of Emily Whitehead, the first pediatric patient with leukemia who was on death's door when she was treated with CAR T cells, and is now, she just completed her sophomore year at Penn. Which is just remarkable. And every day I walk down the 9th floor of the South Tower at Penn between my office and my laboratory, and on the wall are a series of pictures of Emily every day, every year, as she got older and older, from age 5 up through the present, although she's asked to stop taking pictures every year. And there's this movie of Medicine and Miracles that you can stream. It was at the Tribeca Film Festival. It tells the story, and I know the story very, very well, but I still had tears in my eyes watching that movie. So if you have a chance, I urge you to watch it. But the reason I mention this is that it was such a watershed because not only did it bring in a whole field of CAR T therapy and many, many companies that have spun out from that and new therapies that are still being developed, but it changed the culture at Penn. The faculty and the students at Penn started believing that they could cure diseases and that their job wasn't just to write papers or get grants. Their job was to cure diseases. And I've seen that happen, and it changed the work I did in my own laboratory. I actually took on challenging projects that I don't think I would have before Carl down the hall had accomplished all this. And we actually collaborated with Drew Weissman to work on the ability to generate CAR T cells in vivo using RNA to avoid the expensive engineering process ex vivo and to bring the price way down, which I hope will be successful. So this led, following on the CAR T success, a whole series of other incredible successes in gene therapy, in Alzheimer's disease, the mRNA vaccines, et cetera. I won't go into detail about each of those, but I think it's unprecedented in academic medicine to have this number of really breakthrough new approaches occur in such a short period of time. And the beat goes on. And I'm particularly excited because the next generation of faculty who I've watched grow up now in a climate where they think their job is to cure diseases is doing it. And you've all read in the newspaper about the work that led to what I hope will be a cure of KJ Muldoon, the baby at CHOP who was born with a lethal metabolic genetic defect in a liver enzyme. And the baby was born terribly ill, couldn't eat any protein, had to be on dialysis, lived in the hospital. And they sequenced the genome, found the genetic mutation. Kiran Musunuru approached the FDA about the opportunity to correct the mutation using RNA to encode CRISPR, delivered with a lipid nanoparticle to the liver of the baby. Showed that it worked in mice, showed that it worked in non-human primates, got FDA approval in 6 months. It is unheard of. I mean, it really is as close to a miracle as I've heard. Treated the baby, and the baby, suddenly started being able to eat a normal diet, off dialysis, discharged home at the Eagles game on Thursday night. So it's, these incredible breakthroughs continue. So it's truly the best of times and the worst of times. Here we are being challenged with incredible cuts in funding and the necessary infrastructure support for our institutions, while at the very same time producing as close to miracles as I've seen. So here's a list of 41 FDA-approved drugs that have come out of this sort of work at our university, and there are similar success stories at other universities in our region and, of course, across the country. And we continue to invest in the platforms that we think are necessary for the next generation of transformative breakthroughs. AI, as everybody is, something called the Penn Medicine Biobank, where we're enrolling every patient who comes or who's willing to be enrolled to provide blood or to let us use leftover blood from a test they might have had where all the blood wasn't needed. And a platform called Immune Health, where we're measuring the immune response to treatment or disease, because I think the immune system is a built-in sensor that could tell us when you're sick or when the therapy you're taking is working, if only we knew how to read the language of the immune system completely. And so we're measuring millions of parameters of the immune system on as many patients as we can and using AI to make predictions about which patient will respond the best to a given therapy and which patient might have a poor prognosis or a good prognosis. I think this is an enormous opportunity for discovery and for drug discovery going forward. We've also set up several mechanisms to try to keep this engine going, and that includes various forms of sort of venture funds. And I mention them because I think if the NIH and the government is going to pull back, we need to come up with new mechanisms to work together with pharma and with the private sector to keep the whole pipeline moving. And I've begun a series of conversations with CEOs at pharma across the country on how we might respond to the present challenge. I mentioned this internal fund mostly because the ROI has been so impressive. This fund is supported by philanthropy. A number of philanthropists have donated about $15 million so far. We dole it out to great new ideas, mostly junior investigators who are trying something, quote, crazy that wouldn't get funded by the NIH otherwise. The return on investment has been something like $300 million in follow-on funding or support for new companies. 5 companies have spun out from these investments so far. So some in venture feel like work has to be far later in the pipeline before it's likely to give a good return on investment. And my argument is that, first of all, we won't have those things if we don't invest at early stages, and that you can actually make money on early investments if you choose wisely as well. So I think we're going to have to make those arguments and have to make those investments if we're going to keep the region thriving and this system thriving. At a slightly later stage, Penn Medicine has put $50 million into an investment fund where we invest in our own faculty spin-out companies as long as they stay in the region. So it's purposeful to try to build the ecosystem in Philadelphia. And we did that to help our faculty's dreams come true, because we know that you have to work with the private sector to make an idea into a real drug. And so we want to promote their ability to spin out companies and work with the private sector. We also want to show confidence in their ideas to help them bring in other venture funding to support those companies. And I think that's been very successful. We didn't do it just to make money. We have a whole endowment team that invests money to make money. You know, that's their job. This was something separate. This was an investment fund to help our faculty's dreams. But the fact is it's made money too. It's been a good investment. So of the $47 million that we've invested so far, $260 million has come back to Penn and sponsored research from those companies, because they've gotten other venture funding into their companies, and those companies have sponsored work back at Penn. $48 million in license-related payments to Penn, and then, you know, jobs, hundreds of jobs in the region because of these companies standing up. So I think that there are ways that we can, here are some of the companies that we've funded through this process. So I think there are ways that we can think in an innovative fashion about how to keep the engine running and maybe even shorten the timeline to drug development. We've been incredibly successful at making new drugs, but it's still clumsy. A lot of the work we do in academia still gets repeated when it's out in the private sector because some of it's not reproducible, or we didn't do it in a way that's appropriate for FDA approval. If we work together with people who were smart about those things from the very start, we could probably shorten the timeline quite a bit further. We make it very difficult to work with the private sector. As much as we try to simplify it, negotiations are painful. As opposed to grants with the government where we have an agreement and everything is kind of the same under one contract, we have individual contracts for every IP item we license, for every company we spin out, for every MTA, for transferring materials. You know, it's kind of crazy. I think we need to rethink the process of how we work together across this ecosystem, and I think we can lower costs and hasten the process. Pharma and biotech more and more wants to do studies involving humans and wants to get away from relying on animal work if possible. And we have patients. You know, we should be working closely together. We have, more and more, we have a lot of data on patients. Electronic medical record data, genetic data, immune profiling data, as I mentioned. And I think that will be very valuable for sharing so that we can use it to inform drug development. So can we accelerate the pipeline through enhanced integration from the earliest stages? Are consortia of funders, if not the federal government, in venture, maybe sovereign funds, maybe state funds, viable for true investment in the beginning of the pipeline in new ideas? Can we come up with umbrella agreements on how that'll work so we avoid these endless negotiations? And I actually was reviewing one today at Penn, a template of how to set this up. The risk is that we'll make a bad agreement. We'll have a blockbuster that we don't get a good share of back to invest in the pipeline again. But my thinking is that we'll win some and we'll lose some. And that on average, if we pick the set point correctly, we'll come out all right, and pharma, biotech will come out all right also, and we'll save a lot of time and money along the way. I think that's going to take flexibility, but there's nothing like a crisis to encourage people to be flexible. And I really think now's the time. We should take advantage of the crisis to fix some things that really have been broken, but we've all been indoctrinated to accept for many, many years. Could Company X license an entire platform and work in partnership with shared space, with shared staff, with aligned goals? A sort of new model for R&D in pharma where it's not all in-house, but it's not just buying up companies also. There's a true partnership. At one point, when CAR T cells were first being developed, we had 200 Novartis employees in our buildings. It can be done. There weren't legal reasons not to do it. Novartis bought in. They paid for the necessary cost to do that. And we worked together and we won the race to have the first CAR T FDA approved. And it was a race at the time. So I think we need to think about these new models. And of course, some would push back and say academia shouldn't be holding hands too closely with money-making companies. They should be more free of conflicts of interest than that. And I do think we have to maintain academic freedom. We do have to defend the ability of a faculty member down the hall to do whatever experiment he wants to do or she wants to do, not influenced by some agreement between a company and another faculty member. And that's something that's often not appreciated by pharma because they're used to making deals with other companies. And they say that company can't work on X or can't partner with this other people because we have a deal. But in academia, we can't make those kind of deals because we have to defend the freedom of our faculty to explore whatever questions they want. So it will take negotiation and discussion to get these agreements right, but I think it's doable, and I think we need to take this opportunity to do it. Finally, I'll stop here. Can we create facile clinical trial networks with one point of entry, one IRB, and access to electronic medical record, genetic, and immune data? This is a real sore spot for pharma. Getting, especially first-in-human clinical trials and larger phase 2, phase 3 trials, up to speed quickly. And most are going to China or Australia or New Zealand to do their studies because it's too complicated to do it in the US, both for regulatory reasons, but also because we're not good at enrolling patients quickly. And it takes us a long time to get things up and going. And I've begun a conversation in the state of Pennsylvania to try to get all of the major sites to agree on one IRB, one point of entry, and where we could set up trials at scale very, very quickly and make Pennsylvania a go-to place for pharma to do their trials. And I think, again, this is an opportunity in a crisis because at other times, people might not have been so easy to talk to about sharing an IRB, or maybe if we all work together on one big clinical trial, you'll try to take my patients, and, you know. But right now, people are eager to keep that research engine going, and they're willing to think outside the box. So I think this is an opportunity of the time, and I think it could make Pennsylvania a very special place for clinical trials and for partnerships. Thanks for listening to me. If there's time, I'm happy to take any questions. Otherwise, thank you very much. I'm going to take any questions. Are there any? Yeah.
Yeah, I think you make a very good point with the private academic partnerships. But is there any thought of, they are the major beneficiaries of what happens with NIH. Is there any thought about a NIH tax on the pharma industry or some direct way to have them pay for that?
That's a very interesting question. It has been, people have talked about it. The Bayh-Dole Act, which allowed IP to be transferred essentially from the government to the university, was intended to promote the economic success of the NIH investments, and it has worked. It has spurred academic institutions to want to partner with the private sector because there's a possibility of a return on that investment to come back to the institutions. Now, could you tax either a portion of pharma's gain or what's come back to the academy and send it back to the government to support the NIH? You could. We tax all of the Americans to fund the NIH. And one could argue it both ways, and people do argue it both ways, about whether it makes sense to target the tax on the profits or not. But I don't think it's unreasonable.
So thank you for that. It was excellent. Just as I'm an associate dean for research, you talk a lot about the NIH funds cut, and I'm also thinking about NSF and how that funds undergraduates. How do you think this is going to impact your pipeline of students, coming into medical school?
Yeah, thank you for mentioning it. I should have broadened it. The NSF has been hit harder than the NIH actually to date. and the CDC likewise. And there are other federal funding agencies that are similarly affected, and the indirect cost discussion is relevant to all of them. In fact, the NSF has already cut their indirect rates. It's only that the budget of the NIH is bigger than any of those, so it's a bigger piece of the pie. The NSF has focused on education really in almost all of their funding opportunities, and so the relative impact on education will be even greater for the NSF cuts than for NIH. Again, it's just that the relative budget is much higher at the NIH. As I mentioned, I'm terribly worried about the effects on training and the pipeline. And I also think, you know, you've talked to your students. When I talk to our students, they're very discouraged about even a career in the private sector as well as in an academic setting. They're just discouraged. And many of them, in a way I haven't heard before, thinking about completely different careers. And I think that'll take a long time to recover from. It's less so, in my experience, with our medical students. They don't see the funding cuts as the main challenge to their careers. So the enthusiasm of our medical students remains very, very high.
I love that you talked about the partnership between private organizations and universities. Universities are always expanding their laboratories, and so knowing that universities are always looking for room to expand, and knowing that it's financially beneficial in the long run for both the university and the private organization to share a space. Do you see institutions like yours starting to keep the requirements for private institutions in mind when they're starting to expand, so trying to build that cohesion into a new facility?
Yeah, I think we need to think about that in a more innovative way than we have. I'm not sure they're always expanding. Most places aren't expanding right now, and in fact are looking for ways to contract. But traditionally, over the last couple of decades, they have been expanding. And there have been examples of shared space between a company, let's say, and an academic institution. And I think we need to think more about that. I think my time is up. Thank you so much.